Hi, this question says a diver jumps off a high board with a velocity of plus 12 meters per second. So here's the dive board, here's the high board, and we can picture this diver jumping up in the air, stopping, and then returning to the water. And he jumps up with a initial velocity. So VI is equal to plus 12 meters per second. The high board is 6 meters above the water. It's tempting to just draw two lines and put 6 meters, but that's a bit of a trap. We'll come back to this in a minute, and I'll show you why this is a little bit incomplete. And then it says she. What is her velocity as she reaches the water? So here's an important point on these free fall questions. We can start and stop in different places for a given physical situation. In this case, we are starting at the high board and we are ending at the water. So returning to this thing about the height of the board, if I start at the high board and I end lower, then my displacement is negative 6 meters. So by taking into account where my start and where my end is, I can get the sign of the displacement. It says what is her velocity as she reaches the water, so we want to find VF is equal to that. So there's my visualization. She jumps up from the high board at 12 meters per second in a positive direction. She eventually reaches the water and has a final velocity, and the dive board is 6 meters above the water, and because she goes from the dive board to the water, that displacement is minus 6 meters. And the next thing we do is we make our list. So I can say my VI is equal to plus 12 meters per second. I can say that my VF is what I want. I can say that my displacement is minus 6 meters per meters, and I can say that my acceleration, as always, is minus 10 meters per second squared. So my job now is to combine these things to get an equation that links these parameters. And the one that comes to mind is Vf squared is equal to Vi squared plus 2a times delta x, my displacement. So Vf squared is equal to plus 12. It's a thing, so let's put it in parentheses and square it. Plus 2 times minus 10 times minus 6. So Vf squared is equal to 144 plus minus 10 times minus 6 is plus 60 times 2 is 120. So when I add these two guys together, I get 264. So VF is the square root of 264. VF is equal to plus or minus 16.25 meters per second. Now that's the mathematical answer. When I look at my diagram though, it becomes clear that the true VF is equal to minus 16.25 meters per second. And at this stage, we'd expect students to be able to distinguish between the validity of the positive answer and the validity of the negative answer. From the physics situation, you know it's a negative velocity. couple of points to watch out for. First of all, if you have these two signs and you make a mistake on your -6 meters per second and call it +6 meters per second, you'd end up with a negative number for this 120. And you'd end up with basically +24. And you get the answer of 4.9. So there's a number of traps in here. You've got to work your way steadily through them. So there we have it.